Welcome to our lesson on percent error. So, percent error is a calculation that shows us how far our experimental value is different from the accepted value. The experimental value is what we're going to measure when we're in the lab or when we're gathering data. The accepted value is what was accepted, the accepted or correct value. There is a formula: experimental value minus accepted value. Notice the absolute value brackets here, which ultimately means if you reverse these two and say it's accepted value minus experimental value, it doesn't matter. Writing it either way works just as well because we're not going to be working with negative numbers. We're looking for the absolute value of the difference between those two. Divide those by the accepted value and multiply by 100%. Might look like a complicated formula, but don't think too long and hard about it. Guys use this formula all the time. Anytime you get a test back, you take a look at the score, you got a 48 out of a possible 50. Almost every single one of you guys very quickly turns that into a percentage by finding the difference, 48 minus 50, and dividing it by 50 to see that, hey, you missed 4% of the test. You got a 96%. Quick example. So water boils at 100 degrees Celsius in lab. Eric and Karen recorded a temperature of 99.1 degrees Celsius when their water boiled. What is their percent error? All right, well, I always start with the formula I'm going to need. And again, you can see I'm using my symbols here. I'm not writing out the whole word. That saves me a little bit of time. I like to list out my variables. I think that helps. It's not something you have to do, but when I look at all these just letters over here, I'm not always sure what I need to plug in. So listing out my variables helps. I look back at the word problem, my experimental value, when they were in the lab, they got 99.1 degrees. That's my EV, my experimental value. The actual value, the accepted value, is 100 degrees Celsius. That's when water boils. And the question is asking, what is their percent error? So percent E, question mark. All right. Luckily, our formula is set up that we already have our percent error isolated or being solved for on a side by itself. Sometimes we'll have to isolate the variable we're looking for, but in this particular question, our formula is set up so that we're going to get the value that we want by plugging in these values. So let's go ahead and do that. Our experimental value, 99.1 degrees Celsius minus 100 degrees Celsius divided by 100 degrees Celsius. Please don't skip this step. I'll explain in just a second how I grade, and I will be looking for this step. You see we have a mixed operation here where we have a subtraction followed by a division. We don't want to do it all at once, so do that subtraction step first. Now we can go ahead and do the division, and we find a percent error of 0.9%. So let's take a look at how I would grade this. And yes, I am very particular. Take your time with these types of problems. They're worth a lot of points. Again, I am very particular, so I'll hit you for a lot of points as well. I like to list out my variables. I think it really, really helps. If you're not the biggest word problem solver in the world, my advice is list out your variables. However, it's not required, and I'm not going to grade it if you do or don't. So that's up to you. What I am going to grade is I need to see the formula. No values filled in, just the formula that you're using to solve this particular equation. Again, we got lucky and our percent error was isolated. If there ever is a formula where you need to rearrange the variables to isolate what you're looking for, I would expect to see that isolation completed. So 1 point for stating the formula. Next, you see I have all my values shown. This is my work shown. This first one here, 99.1 degrees Celsius, you're going to get 0.5 for having the correct value, 99.1, and 0.5 for the unit. So if you're not putting a unit there, I'm taking off points. You absolutely have to have a unit, in this case, degrees Celsius. Come over here to our accepted value. I've plugged in my AV, 100 degrees Celsius. Once again, It's a 0.5 for the value. Yes, I've got the right value. I read the word problem correctly, 100, and plus 0.5 for the unit, so degrees Celsius. Down to the bottom, once again, there's my my accepted value. I need 0.5 for the value and 0.5 for the unit. So stating all of the problem correctly is worth 3 points of the final problem. Hey, there's that step I was telling you not to skip. Later, when we do significant digits, you'll see why it's important not to skip those mixed operations. So we've got a mixed operation, we have a subtraction, followed by a division. That's a mixed operation. So we want to make sure that we show our work. Once again, we've got 0.5 for the correct value, 0.9, and 0.5 for the unit, degrees Celsius. You're going to get 1 point for doing that calculation correctly. 99.1 minus 100, don't forget it's absolute value, so we get rid of any negative signs if we had them. And on the bottom, hey, we did restate our 100 degrees Celsius, so 0.5 for the value and 0.5 for the unit. Finally, we're ready for our last step. We do the division. 0.9 divided by 100 times 100. We get our percent error of 0.9%. And that final part of the problem, you're getting 1 point for the correct calculation, 0.5 points for the correct unit, in this case percentages. The degrees Celsius canceled out. You're left with just percent. And finally, 0.5 for the correct number of digits. We'll cover digits in a later unit, so soon you'll be expected to know where and how to round your final answer, and that too is worth 0.5 points. At the end, this question is worth 9 total points. If you just wrote the correct answer, you only got 2 of those 9 points. So you get like a 23%. Make sure you guys are showing your work. Very, very important. You do not want to get a 2 out of 9, even though you have the correct answer. So show your work. It is expected of you in this class.